Hi, welcome. In this video, we will solve problem search in rotated sorted array asked by companies like Amazon, Microsoft, Google, Apple, and Facebook. Welcome back to one another video. Okay, so let's check this question search in rotated and sorted array. So there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated to an unknown pivot index. Okay, so such that the resulting array is nums k, num k plus 1 to nums of n. Okay. Let me make all these things clear. Okay, you can quickly go through this question. Okay, and you can understand bit of few things like given an array nums after the possible rotation and an integer target. So one target is also given. Okay, return the index of the target if the nums it is in the nums, or -1 if it is not in the nums of array. Okay, so you must write an algorithm with the big O of log n runtime complexity. Okay, so let's quickly understand it. Let me quickly copy this and let's understand the problem statement first. Okay, let's quickly see what is sorted and rotated array. So here you can see I have an array with these values. Okay, so basically suppose this is your one sorted array 1 2 3 4 5 6 7. Okay, and how the sorted and rotated array will be look like. So this is sorted array. Okay, and if I want to rotate it, okay, so what I will do, I will take one pivot element. Okay, it can be 4, it can be 1, it can be anything, and you can simply rotate it. Okay, maybe in clockwise direction or in the anti-clockwise direction, in left or right. Okay, it's up to you. So if you rotate it, okay, if you rotate it, now rotate it also depends on by how many places. So suppose here you have rotated by 3 places. Okay, so rotated by 3 places or units. So this 4 will come after the 3 units. Okay, so 1, 2, 3. So can I say here it come 4? Then I will have 5, 6, 7, and 1, 2, 3, like this. So if I'm basically rotating by 3, so it will be like here. Similarly, right, if you take one element, like suppose 1, and again you rotate it, it will be again move in this direction, the other numbers will come in this direction. Okay, so this is how rotation looks like. And now you can see once you have rotated this array. Okay, so there is a difference is now in sorting. Okay, here you can see this was the complete sorted array. If I represent it in a graph, so it will be completely as like sorted array. Okay, like this one. But here the things are a bit different. Here, here the things like here there is a breakdown. Okay, so from 1 it will move in this direction, something like this, and from here it will move like this. So there is a breakdown here, like, but this is also again, so this was sorted completely from starting to left is completely moving in a certain direction, it is completely increasing, but here there is a sudden drop, and this is what your pivot element. Okay, this is what your pivot element, from where there is you are getting a certain drop. Okay, so this is about sorted and rotated array. Okay, sorted and rotated array. Now let's come to the question. Okay, what we need to do, we need to find the target element in the sorted and rotated array. So suppose 4 5 6, I am taking the same example nums. Okay, so I have 4 5 6 7 0 1 2. Okay, and if I want to find a target element, like here the target element is 0. If I'm going to find the target element 0, one approach that can be a brute force approach. Okay, that can be applied is like you can simply iterate one by one. Okay, is 4 is equal to target? No. 5 is not equal to target? No. 6 is equal to target? No. 7 is equals to target? No. 0 is equals to target? Yes, it is. You can simply return that index of it. Okay, so you can simply return I. Right. So yes, this we can easily do, right? The time complexity of this approach will be big of n. We are not taking any space, so space complexity will be constant. Okay, but this is one of the method. Okay, we are not going to write any code of it because this is a simple linear approach. By simply linearly, you can find it. But since right, the array is sorted, the array is different. Okay, this is different from the general array. This is sorted. This sorted and rotated. So we should come up with a more optimized approach rather than finding a single element that can be found in any generalized array. Okay, so what we can do? Let me quickly copy this. Now here, since the since the nums array is sorted and rotated. Okay, sorted and rotated, so we will come with some better approach. Okay, and you can see you have given one sorted array, so are you getting any hunch of binary search? We can apply binary search. Yes, right, we can apply binary search here. So how we can apply binary search? Because generally we apply binary search in a sorted array. Okay, the array needs to be completely sorted. Okay, and how we basically apply binary search, let me quickly explain you few terms of it. Okay, so suppose this is one sorted array 1, 2, 3, 4, 5, 6, 7. Okay, and let me put the indexes 0, 1, 2, 3, 4, 5, 6. Okay, so we take two elements, right? Let's suppose two pointer, let's low and high, or you can take a start and end. Okay, both are same. So then what you will do, you will simply find the mid pointer. Okay, and how you will get the mid? Plus low plus high by 2. So you will do 1 plus 7 by 2, that will be 8 by 2, that is 4. This is your mid. Okay, you will check now. Okay, suppose your target element is given. Okay, it can be 6. So you will check, is your target element is lying, is less than mid? Okay, less than or equal to mid, or is target element is greater than mid? So if it is less than mid, that means there is a chances that your target element can be here, and if it is greater than mid, then there are chances that it can be here. Okay, so here you can see the target element is not less than mid. Okay, it is greater than mid. So I can completely ignore this part. I can completely ignore this part. I can completely ignore these elements 1, 2, 3, 4. Now my focus point is from 5 to 7. So what I will do, I will change my pointer. Okay, and it will be now mid plus 1, that will be low here. Again, what we will do, we will find the mid. So if I do 4 plus 6 by 2, so that will be 10 by 2. You will get this as mid. Okay. Again, you will check first, is this is your target element? Is it equal? Okay. So yes, it is basically equal. It is completely equal. You can simply return, or you can still again check, is it less than equals to mid? So yes. So now your focus will be here. Like it is, or if it is not here in this range. So basically you can see, so suppose we have n elements, okay, and we are by binary search, we are directly reducing our size by half, n to n by 2, then n by 2 to n by 4, then n by 4 to n by 8. Okay, we are directly reducing it. How? Because we are getting a guess, like if it is less than equals to mid, that means it is not present greater than mid. Okay, वो greater than mid में नहीं होगा, so we can simply ignore it. Okay, and that's why the time complexity it's of a binary search known as lightning fast method. The time complexity is because of log n. Okay, very highly optimized time complexity than your linear search. You can just simply assume like this. Suppose n is 1024. Okay, so how many iterations will be required to get a target elements? 1024 iterations, right? Because of n. But if you are applying binary search, it will be log n. Okay, log of 1024, that is 2 power 10, 1024. Okay, and the base is same. So I will say only 10 iterations required in binary search and 1000 iterations required in linear method. Okay, so this is linear search, this is binary search. That's why it's known as lightning fast method. Now let's quickly see, let's quickly move to our point, how we can find the target element in sorted and rotated array. Okay, so here let me quickly copy these items. Okay, and let me put it here, and suppose target is 0. So how I will find it? Basically, again, we will apply the binary search. I will take low pointer, I will take one high pointer, and I will find the mid. Okay, so 0 plus 6 by 2. Okay, what will be my mid? Mid my will be at 3. This will be my mid. Okay, now I will check. Now I will check which part is sorted or sorted or not. Okay, I will check for the path. So first, identification, you can say identify the sorted region, because you will apply binary search in the sorted region. So the goal is here, identify the sorted region. What is the sorted path? Okay. So how you can check basically? So you can check it's simply, you can simply say your first element. Okay. Here we are using nums. So I will simply say my nums of 0. Okay. Is it less than or equal to my nums of mid? Okay. So I'm just checking 4 is less than equals to 7. Yes, this is right. 4 is less than equals to 7. Okay. So that means this region is completely sorted. Okay. This region is completely sorted. Okay. So we can apply binary search here. Now, what I need to check next thing, I just need to check this thing. Is my target is also lying here? Okay. So is my target is less than nums of 0 and greater than equals to nums of mid? Okay. Is my target is lying here? No, that is not the case. Okay, your target is not lying here. So what I will do, I will simply ignore it, because this like this region is not going to work because my target element is not lying here. So what I will do, I will simply update my low pointer and I will update it here. Okay. And now I will always remember, okay, like here I have not taken it, but whenever you are getting mid, you first need to check is your mid is equals to target. Okay. Because if the mid element is equals to target, then there is no need to find out the sorted region, right? So if I say the zeroth step will be check the mid element is equals to target. Okay. So now here will be my low pointer. What I did basically, I simply said low is equal to mid plus 1. So low will be here and high will be here. Again, I will find the midpoint. Okay. So 4 and 6 by 2, that I will get 5 as my mid. Okay. And again, I will check is my mid element, that is 5, is equals to 0. That is not true. Okay. So what I will do, I will compare. I will compare that which region is sorted or not. So again, I will compare that from nums of 0, from nums of 0 less than equals to my mid element. Okay, that is nums of mid. Is this region is sorted? Is this region is sorted? Okay, so no, it's not. Okay, what I will do, I will check the other element. I will check. So now the next element will be sorted region. This will be the sorted region, right? I can simply say that this will be the sorted region, but I will check that is my 0 is lying here. Okay, the sorted region that I'm assuming is my 0 is lying here. So what I will do, I will check is nums of mid is less than equals to my target and less than equals to my last element. Okay, you can simply say last index. So target is not lying here. 1 to 2, target is not here. So what I will do, again I will say that this region is of no use. Okay, I don't want to use this region. So what I will do, I will simply shift my high pointer to mid minus 1 and it will be lying here. Okay, now my low pointing to 4, my high is pointing to 4. What will be my mid? My mid index will also be 4. Okay, these all are indexes. So my mid index will also be 4. Okay, and I will check is my mid element. Okay, it's my mid element, that nums of mid is equals to target, and yes it is, it is equals to 0. So what I will do, I will return the index, I will return mid, that is equals to 4. So basically, this is how you can solve this question. Suppose, like in one case, you can assume that suppose you are not able to find the target element, right? Again, you will compare the same thing. Is nums of is 0, is 4 is basically you will compare is 0 is lying between your mid, that is your 0. So suppose like your target element is something different. So suppose 3. Okay. So is your 3 is lying between here. like is your 3 is lying between here? So it's not. So you will ignore it. You will check the other term. Okay. And again, eventually this will break. Your low pointer will eventually will become high, greater than high pointer. And here, this will be the stopping condition. You will basically stop here. Okay. So this is how you can apply this algorithm. Okay. One of the lightning fast method. Okay. Always remember what are these steps. We first need to check out the our mid element that is equals to target or not. If it is target directly, that will be my answer. Okay. Then I need to identify the sorted region. Okay. Which is my sorted region. And then second, what will be the thing? Okay. I need to find is my target lie in the sorted region. Okay. So if it is lying in my sorted region, I will simply check out in the sorted region. Otherwise, I will simply move to the next region. Okay. And this is how you will work. Basically, you will check is it lying in the sorted region, because if it is lying, then you will simply proceed. If it is not lying, you will simply move to the next region. Again, you will divide it into two parts. Again, you will check out the two parts. One is sorted region, one is second is not sorted region. Okay. So this is how we can solve this question. And in the next video, I will show you how you can implement the code of it, whatever we have studied just so far. Okay. In the next video, we'll see the code of it.